Hello everybody, and welcome to topic number 20, dividing polynomials by long and synthetic division. Our objectives today, we're going to show you how to divide polynomials using the long division method, and then again using the synthetic division method. So we've seen how we've divided before with polynomials. Remember, when we divide a polynomial by a monomial, we simply go through and divide the numbers and subtract the exponents. So for example, when I have 10x cubed minus 5x squared plus 20x and I divide it by 5x, we would simply take each one of the terms and we would divide it by 5x. We would divide the numbers and we would subtract the exponents. So 10 divided by 5 is 2. x3 minus x1 is x squared. Negative 5 divided by 5 is negative 1. X squared minus 1x leaves me with 1x. 20 divided by 5 is 4. Then here the x is canceled, and this would be left with our answer. Same thing here. We're going to take each of these terms. We're going to take away 2 of the x's, 1 of the y's, and since there's no number here, it's like dividing by 1, so we're going to leave the numbers the same. So 3 divided by 1 is 3. 5 x's take away 2. I have 3 x's. 2 y's take away 1. This term has 1 y. 15 divided by 1 is still 15. 3 x's, you take away 2 x's, you have 1 x left. Here we take away the y because we only had 1 y there. 2 x's, you take away both x's, that goes away. Same thing with the y. Since both the terms canceled here, we have to put a number there, so we will put a 1. And then negative 6x divided by x squared. Negative 6 divided by 1 is negative 6. Here in this case, we would get rid of 1x and 1x here, which means we would have 1x on the bottom and still a y at the top. So this is what we've seen before. Anytime we've done division, we've always taken a polynomial and dividing it by a monomial. If we didn't do it that way, then we did factoring. But what happens if you have something that cannot be factored and it's not a monomial? What are some ways that you're going to be able to divide it? That's the intent of this video. We're going to show you 2 different techniques depending on the polynomial that you're dividing by to do it. The first method is something that we all learned back in grade school. It's using long division. And by long division, I mean the old school way where we used to take a number and divide it by another number and go step by step. So if you remember, when you started learning math, you probably learned division this way, where we have the inside number divided by the outside number, and we would ask how many times does 5 go into 1, and we would get nothing. And so we would look at 12 and we would say how many times does 5 go into 12, and it would be 2. So we would put a 2 up here, and there would be a remainder of 2 here, because 2 times 5 is 10. And then we would minus 10 and we would get 2, and we would drop down the rest of the parts. And then we would start again, how many times does 5 go into 2, and so on and so forth. This is exactly what we're going to do here. We're just going to do it with polynomials. So we're going to take polynomial terms and divide it by each other until we run out. It's going to look complicated, but I think if we kind of get into the technique, we see the rhythm of it. It's really just a pattern that we're trying to follow as we go through and divide the polynomials. So let's show you an example here. I want to take 2x squared minus 17x minus 38, and I want to ultimately divide it by 2x plus 3. So this will go on the inside. So 2x squared minus 17x minus 38, and I'm going to divide it by 2x plus 3. And I know I'm going to use long division here because of this term. Because there's a number in front, I'm going to have to use long division. Later on you'll see we'll use synthetic division, but we can only use synthetic division if there's no number in front there. So to start this off, we're going to take the front 2 terms, which in this case is 2x squared and 2x. And we're going to come off to the side and we're going to divide them. 2x squared divided by 2x. Well, 2 divided by 2 is 1, and x squared divided by x just gives me x. So 2x squared divided by 2x gives me x. And I'm going to place it right above the 17x because those are like terms. Well, then what I'm going to do is I'm going to take that x and I'm going to multiply it back into what we were dividing by. So in this case, we're going to do x times 2x plus 3. And we're going to distribute this out here. X times 2x gives me 2x squared. Now that's a good thing. These things should always match here as we do it. X times 3 is going to give me 3x. Now this is usually the trickiest part with long division of polynomials. When we do it, we always want to make sure we subtract it. So we're going to take this and we're going to turn this into a subtraction. That way these cancel out. That should always happen. But when we turn it into subtraction, we're not just turning the front term into a subtraction. It means we're taking the opposite of all the terms here. So this plus sign will now become a negative sign. And you can think of it as we're doing the opposite of what's here. So everything has to be taken the opposite of. The front terms should always cancel out, which they do here. And then I'm going to go through and do what I have here. Negative 17 minus 3 is negative 20x. And we'll drop down the negative 38 here with it. Now we're going to start the entire process again. We're going to look at the front two terms. I've got a negative 20x and a 2x. Those are the things that I'm going to divide. Negative 20 divided by 2 is negative 10. X divided by x cancels. So it simply leaves me with a negative 10. Now I'm going to take that negative 10 and go back and multiply it by 2x plus 3. So negative 10 times 2x is negative 20x. And again, these should always match at the beginning, so they do. Negative 10 times positive 3 is negative 30. But again, the key here is we're going to flip the signs. And I'll make sure I go back up here and put it up here. Before we go through and combine anything, we want to go through and flip the signs. So the negative here becomes a positive, and the negative here also becomes a positive. These should always cancel out. The front term should always cancel out. If they don't cancel out, something wrong happened when we did it. Here we're going to have negative 38 plus 30. That leaves me with a negative 8. Now, I only have a constant here left, which means I'm done, because I can't really divide that by 2x here. So this goes through, and this becomes our remainder. It's like when we did long division and we couldn't simply divide into something. The rest of it would just become our remainder. So my final answer is this, but with the remainder. So my answer, we would have x minus 10 minus 8 over, and then if we have a remainder, we put it over what we divided by, 2x plus 3. So again, this is the long division method. It's really just going through, we're dividing the front terms, we'll multiply them back in, we'll flip the signs, and then we'll cancel out the front and bring down anything else that goes with it. And then we'll do that until we cannot divide any further. In this case, because there's just an x here, once this degree is lower, this is degree 0, this is degree 1, because it's got the exponent of 1. Once this degree is lower than this, that means my problem is all done. Let's do the same for this next problem. Now, I want you to look at this polynomial here. This is 27x cubed plus 8. You're looking at it probably a little bit funny because it goes from an x cubed and then it goes to an 8. It's really kind of missing an x squared or an x on the inside. So when I go to write this, I'm going to use the placeholders. And anytime we need to use a placeholder, it's a placeholder of 0. And the reason I want to do that is I want to make sure all of the variables from x cubed all the way down to the constant is covered. So I'm going to start it off. This will be 27x cubed plus 0x squared plus 0x plus 8. And those zeros will come in handy, especially when I go through and I combine. Then we'll have 3x plus 2 here. So again, we'll start off. We're going to take the front two terms, 27x cubed, and divide it by 3x here. 27x cubed divided by 3x gives me 9x squared. I'm going to put the 9x squared above the 0x squared because they're like terms. And now we're going to go back in and multiply 9x squared by 3x and 2. 9x squared and 3x give me 27x cubed, which is good. These should match. 9x squared and times 2 gives me a positive 18x. But now I want to make sure I go through and I flip the signs before I combine. So the positive 27x cubed becomes a negative, and then this positive 18x squared, we're going to go and change it to a negative 18x squared. If we did this right, the front term should always cancel, which they do here. 0 minus 18x squared gives me negative 18x squared, and I'm going to bring down the rest of these things with it, because this is the remainder of the polynomial that I have left. And now we're going to divide again. We're going to take the front term, which is now negative 18x squared, and divide it by the 3x here. Negative 18 divided by 3 is negative 6. X squared divided by x is x. So now I have a negative 6x. And now I'm going to go back through and take that negative 6x and multiply 3x plus 2 by it. So negative 6x times 3x is negative 18x squared. These match, so that's good. Negative 6x times 2 is negative 12x. Once again, once we get to this point, we're going to go through and flip the signs. They're both negative here, so now they're going to both become positive signs. The front terms cancel. 0 plus 12x is 12x, positive 8. Now if you notice here I've got 12x and 3x, they're both the same degree, so I should be able to do one more division and then be all done. So I'm going to take the 12x, which is the front term here, and divide it by the 3x here. 12x divided by 3 gives me a positive 4, and I will take that 4 and multiply it back into 3x plus 2. 4 times 3x is 12x. 4 times 2 is 8. Once again, one more time, we're going to go through and flip the signs. The positive 12x becomes a negative 12x, and the positive 8 becomes a negative 8. The front terms cancel, which is expected, but this time 8 minus 8 also cancels, and it leaves me with 0, which remember, when we get down to the end and we just have the number left, this is my remainder. So it tells me there is no remainder, that this goes evenly into this. So my final answer would simply be 9x squared minus 6x plus 4. So again, this is long division polynomials, and we have to use long division anytime there's a number in front of the x. Anytime you see a number in front of the x, you have to use long division. If there's not a number in front of the x, that's where the second division comes in that we are going to show you here in a second. But again, make sure we divide the front terms. The key here is always making sure we got to flip the signs before we go through and combine anything. So as we talked about, the other type of division is synthetic division. And typically people like this because it's a little bit faster. But in order to use synthetic division, we have to have a couple of things. There can't be any number in front of x, so it really should be a 1 here. And we can't have a power here on x. It really just needs to be x by itself. It does not matter if this is a positive or a negative number here, as long as there's no number in front of the x, just a 1, and the exponent has to be 1. There's no other number of that. If we can do that, then we can use synthetic division. So when you go back to the previous problem, you see 3x plus 2. That's why we couldn't do it. The coefficient was 3, the exponent was 2. We could not use synthetic division. Now, the process of synthetic division is pretty straightforward. We're going to divide 2x squared minus x minus 10 by x plus 2. In order to do this, we're going to put a box up here in the corner. And always in this box is going to go the opposite of the number that you see that you're dividing by. So since I'm dividing by a positive 2 here, in the box goes a negative 2. Now we're going to take what we're dividing by, and essentially we're going to get rid of any variables. We're just going to leave the numbers. If it's got a negative subtraction, we're going to treat it as a negative sign. So this would become 2, negative 1, and negative 10. And then we're going to put a line down here. And then we've got two rules. We're either going to move down or we're going to move sideways. If we move down, then we add or subtract. If we move sideways, then we multiply by what's in the box. So in this case, we would always multiply by -2. Now the first number we always have, we're going to just bring that down immediately. So we're going to start, we'll bring down the 2, and now we're going to go sideways, and so we're going to take this 2 and multiply it by a -2, and we're going to get -4. Then we're going to move down again. So in order to move down, we either add or subtract. We basically do what the signs say here. -1 minus 4 gives me -5. And then we're going to move sideways here again. -5 times -2 is +10. And we've got -10 plus 10 equals 0. And when we get to the last number here, we're going to put a box around it just like we did here. So I want to go back and remember that when we did this, we got rid of the variables. So this used to be the x squared, the x, and this here was the constant. Now when we get down to our answer, it's very similar, except this box here is our remainder. So if we have a number left here in our box, that's our remainder. Because we have a 0, that tells me we don't have a remainder. It goes in perfectly. This goes perfectly into this. The first number after the remainder is the constant. And the second number here would be the x. And so this actually is our answer down here. It tells me my answer is simply 2x minus 5 and no remainder. So our answer is simply 2x minus 5. If we had another number over here, let's say we had a 8, then this would have been the x squared. And so it would have been 8x squared plus 2x minus 5. And then we would have kept going on forever there as we do it. But again, we can only use synthetic division if there's an x by itself. It's a lot faster, but we can only do that if x is by itself there. Let's show you again with this problem. So again, we're going to put a number in the box. We're always going to take the opposite of what's here. So I'm going to put a 5 here in the box. Then we're going to get rid of all of the variables. We're going to have no more p's, and we're just going to put the numbers. So again, this is a 1, so we're going to have a 1, a -10, a 20, and a 26. And again, the rules are simple. We're going to bring down the first one, and if we go sideways, we multiply by 5, and if we go down, we add or subtract by the number. So in this case, 1 times 5 gives me 5. -10 plus 5 gives me -5. -5 times 5 is -25. 20 minus 25 is -5. 5 times -5 is -25. 26 minus 25 is 1. Since there's nothing else left, this becomes my box. So again, this is my remainder. This tells me we did this. This does not go evenly into this. We're going to have some sort of remainder. This ends up being my constant. This will end up being x, and this will end up being x squared. And essentially, these numbers become the coefficients in front. So my final answer is x squared, 1x squared, minus 5x, minus 5, plus, because the remainder is positive, plus 1 over, if we have any remainder, we put it what we divided by in this case, p minus 5. All these variables here shouldn't be x's, they should be p's. But again, we put the remainder over whatever we divided by there at the end. Let's do it one last time. Again, we could use synthetic division because x is by itself. Again, you're looking at this polynomial a little bit funny because, again, it's missing a bunch of terms. But remember, we can write this as x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1. So when I go to write this in synthetic division, we're going to have those placeholders again there with it. Inside the box goes the opposite of this one. So inside the box goes a 2. We'll start with the x to the 5th. I have a 1, I have a 0, I have 1, 2, 3, 4 zeros, put 4 zeros here, and then our constant is a 1. We'll bring down the first one. We'll always multiply by 2. So 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 gives me 4. 4 times 2 gives me 8. 0 plus 8 gives me 8. 8 times 2 gives me 16. 0 and 16 make 16. 16 and 2 make 32. And 1 and 32 make 33. And we'll make sure we box off the end here. So again, writing the answer, the box is the remainder. The first one after the box is the constant. And then this will be x, and then we'll just count up. X squared. This will be x cubed. And this will be x to the 4th. So when I go to write my answer, I have all my coefficients right here. I have x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16 plus 33 over what we divided by here, x minus 2. So again, synthetic division, a lot easier to do. You just have to remember we can't always use it. So if there's a number in front, you have to use long division to solve it. If there's no number in front, then you can use synthetic division to be able to go through and solve it.